In today's class, we'll be looking at the derivation of the diffusivity equation for compressible fluid in radii flow. Derivation of the diffusivity equation for compressible fluid. Example of compressible fluid are gases, air, etc. in radii flow. Also, record the equation we derived for radii flow. We said that 1 over arrow d the arrow of arrow rho v is equal to the phi rho divided by what? Where we said that v is equal to 2.637 times 10 raised to the power minus 4 k all over mu dB the arrow. Now, but for gas, remember that when we did for slightly compressible, we only use formula for what? V. Now, when you are deriving for compressible fluid, you know that for compressible fluid, the density is very comparable. So, you can't neglect the density. So, we will include the density of the fluid in our diffusivity equation. For gas, we know that the density of gas is equal to P mg over Z ROT. Where P here is the pressure, M here is the molecular weight of the gas, Z here is your compressibility factor, RO is your universal constant, and your T here is your what? Temperature. So for us to derive the diffusivity equation, we first of all substitute the value of density, the equation of density, into this equation. In place of density here, we are going to replace it with this equation. In place of velocity, we are going to replace it with this equation. That's what we are going to do. So let's start. For us to do that, this will give us 1 divided by arrow, which is this equation, d the arrow of, we have arrow, which is arrow. Now we have density. What is our density here? Our density is what? P mg divided by what? Z arrow t. So this becomes our density. Then we have our velocity. What is our velocity? So our velocity is equal to this. So this becomes, this is times this, times velocity, which is 2.637 times 10 raised to the power of minus 4k divided by viscosity. So this becomes our velocity. Everything here will be equal to d divided by dt into, here we have velocity, phi. Now here we also have what? Density. What is our density again? So it's P mg over what? Z ROT. So this will give us times what? P mg divided by Z ROT. So we have this.
So how about the P over the arrow?
The P over the arrow. Okay. Thank you. Here we're supposed to have the P, the arrow, before we close the bracket. So we have this. So if that is the case, remember what we did in the last time. In our last class, we said that we factor out what? The constant, which is this one here and this. In this case now, what are the constants? The constant also is this factor parameter. But now, also for gas and for this compressible fluid, we are still going to factor out mg and what? ROT. We factor out mg over ROT. We factor out this one here. Factor out mg over what? ROT. So if we have to factor out that, this will give us mg divided by ROT. Remember, we are removing the constant, which is this one, and over ROT is what? This. So if factor it out, we have mg over ROT, then bring this one out, multiply by 2.637 times 10 raised to the power minus 4k all over mu, multiply the numbers. These two particular parameters are just the constant we have inside this bracket. So we bring them out. This mg over ROT is this, then this one here is just what we have here. Now that I brought them out, let's write our what? Equation. This will be multiplying with what? 1 over arrow, then d the arrow of. Here now, this will be we are left with arrow there. Remember, we have already factored an mg over arrow t. So here now we are left with what? P over z. So this becomes P all over z. Then we put it in brackets. Then dot. Remember, we remove this one, so we are left with what? Dp the arrow. So here we are left with dp the arrow. So we are done with this bracket. We close this. So everything here is just what we have here. Then this is equal to, if you look at this, mg over arrow t is also constant here. So we factor it out. If we factor it out, we are going to have mg divided by what? Arrow t of d all over dt, d all over dt of, since we factor out mg over arrow t, we are left with what? Phi and what? P all over z. So we have this. Now if you look at this, we have mg over arrow t here. We have mg over arrow t here. Can we say that mg over arrow t cancels out? So since you have mg arrow t here, mg arrow t here, you can simply what? Cancel mg over arrow t out. And this one to cancel out what? This one. If that is the case, we will be left with just what? This equation. If mg arrow t cancels out mg arrow t, we are going to have this expression. Since we have this expression now, the next step now is to focus more on the right hand side. Focus more on the right hand side. Don't touch what? The left hand side. Leave the left hand side and then focus on what? Leave the left hand side and focus on the right hand side. So let's focus on the left hand side. Now if you look at this, this is d over dt phi p over what? Z. The same way we did the differentiation for our slightly compressible fluid, the same way we are going to apply the same way to this what? Differentiation. So first of all, differentiate this one here becomes what? Constant. Differentiate this one, this becomes constant. Then differentiate this one, this becomes what? Constant. So let's differentiate this. If we differentiate this one, we are going to have what? To differentiate this one, this becomes constant. So this becomes P all over Z into, all right? Differentiate phi now, we are going to have what? D phi over what? dt. Now we are done differentiating this one. So the next step now is to differentiate what? P over Z. To differentiate this one now, phi becomes what? Constant. So this becomes plus phi. Differentiate the P over the Z, you have d P all over what? Z divided by what? dt. So we are going to have this expression. Remember that the left hand side is still the same, which is 2.637 times 10 raised to the power of minus 4k all over mu times 1 all over arrow d the arrow of arrow p over z dp the arrow. Third, this particular bracket. The next step now is to factor out phi and p over z. Just factor out the constants. Factor out what? The ones that remains constant. So we are going to factor out p over z at what? Phi. If you factor out p over z, we are going to have p all over z. Factor out this, we are going to have this. Now let's open this bracket. If you factor out p over z and phi from here, first of all, factor out p over z, there will be nothing, abi? Then factor out phi. Is there phi here? No. So here we are going to have what? 1 all over what? Phi. So that if phi multiply this 1 over phi, we are going to have what? 1. 1 times this will also give us what? The same thing. So this becomes 1 all over phi d phi all over what? dt. We factor out p over z and phi. From this, we are going to have this. Also, factor out p over z phi from this expression.
If you look at this expression here, there's no P over Z, but there's phi. If you factor out phi, you'll be left with 1. Factor out P over Z since it's not here. If you want to factor out P all over Z from here, you are going to have 1 all over what? P over Z. But 1 all over P over Z is still the same thing as Z all over what? P. So we can simply say that this thing is the same thing as what? Z all over what? All over P into the P all over Z divided by dt. So we are going to have this expression. Factor out P over Z and phi. We have this expression from here. Then remember I said that the left hand side remains what? The same. So here we are going to have 2.637 times 10 raised to the power of minus 4k all over mu dot 1 all over arrow d the arrow of arrow dot p all over z dot dp the arrow. So we are going to have this. Since we have this, the next step now is to apply chain rule. Apply chain rule to the right hand side. Apply chain rule to the right hand side. To apply chain rule to the right hand side, remember that we said from chain rule, the phi all over dt is the same thing as what? The phi dp times what? dp divided by what? dt, such that dp can what? Cancels out. If they cancel out, we are going to have the phi dt. And also apply chain rule to dp all over z divided by dt. If you apply chain rule to this, we are going to have dp over z divided by what? dp dot dp divided by dt, such that dp cancels out. We are going to have what? dp over z dt. So we have from chain rule, this is equal to this, and also this one is what? Equal to this. If that is the case, let's substitute the value of the phi dt in place of here, then the value of dp dz over dp over z over dt in place of dp over z over dt. Let's substitute the value of dt, the phi over dt, and the value of dp over z over dt. So if we do that, we are going to have 2.637 times 10 raised to the power of minus 4k over mu dot 1 all over arrow d the arrow of arrow p all over z dot dp the arrow is equal to p all over z of phi into 1 all over phi. Now we said that our d phi dt is equal to this from chain rule. So let's put this. This will give us dot d phi dp dot dp dt, then plus z all over p dp over z dt is the same thing as this one here. So let's substitute this in place of this. We are going to have plus dp z divided by dp dot dp divided by dt. So we are going to have this. So since we have this now, the next step is to factor out dp over dt. Factor out dp over dt from the right hand side, which is this side. So if we factor out dp over dt, we are going to have p all over z into phi into dp all over dt in bracket. If you remove dp over dt from here, we are going to have what? 1 all over phi d phi all over what? dp. There's no dp over dt again. That's what we have here. plus Z all over P. Remove the P dt from here, we'll be left with just what? This one here. The P over dt is already out here. So we're going to have dP all over Z divided by what? dP. So we are going to have this. Now, since we have this, now we have already factored this. We can also put dP over dt at the ending of this bracket. It's still the same thing. So since we already have this, the next step is to differentiate dP over dz with respect to dP. Differentiate dP over dz with respect what? To dP. So for us to differentiate, I can simply say that we are still at the right hand side. So this will be equal to P all over Z times phi times dP dt into 1 all over phi d phi divided by dP plus Z all over what? P. Now let's differentiate P all over Z with respect to dP. Differentiate P over Z with respect to what? To dP. If I are to do that, let's put it in another bracket. First of all, since we are differentiating two parameters, right? First of all, differentiate P. If you are differentiating P, 1 over Z becomes what? Constant. So we are going to have 1 all over what? Z. Differentiate P. If you differentiate P, you are going to have what? 1. So 1 times 1 over Z, we are going to have 1 all over Z. Then the next step now, since if you differentiate P with respect to dP, we are going to have dP over dP, which is what? 1 times this, we are going to have 1. Then differentiate, that is plus. Differentiate what? 1 all over Z. If you are differentiating 1 all over Z, P becomes what? Constant. So we are going to have plus P. Differentiate 1 over Z. Differentiate 1 over Z. Well, remember that this is 1 all over Z. 1 over Z is the same thing as Z raised to the power of minus 1. If you differentiate this will give you what? Minus what? Z raised to the power what? Minus 2. Which will be, well, if you differentiate this, I'm going to have this. So this thing can also be written as 1 all over minus 1 over what? Z square. But now we know that Z is a function of what? P. Z is a function of P, is depending on P. So instead of differentiating this one the way we differentiated P here, we have to differentiate 1 over Z now implicitly. Differentiate 1 over Z implicitly. So if you differentiate 1 over Z implicitly, we know that from implicit differentiation, if you are differentiating Y, if you are differentiating 2Y, you are going to have what? 2 dy what? Dx. Because Y is a dependent variable that depends on X. So differentiate this one now, you're going to have something like that. You add dy ds what? To it. The same concept is applied here. Z is dependent of pressure. So if you are differentiating Z here, you have to differentiate Z implicitly. So if you differentiate Z, you have to add what? dz all over what? dP to it. So this now is from where? Implicit differentiation. If that is what you are going to have, so if you differentiate 1 all over Z here, you are going to have minus 1 all over what? Z square dz divided by dP. Then you close this bracket. This one is just for this bracket. This one is the closing of this one. Then we close another bracket, which is this one. So if you differentiate dP over Z related to this, you are going to have 1 all over Z plus P into minus 1 over Z square dz dP. Then you close the bracket. So if that is the case, this will give us, okay, let's write the left hand side. The left hand side is 2.637 times 10 raised to the power of minus 4 k all over mu dot 1 all over arrow d the arrow into arrow p over z dot dp the arrow. So we are going to have this. So this will give us 2.637 times 10 raised to the power of minus 4 k divided by mu dot 1 all over arrow d the arrow of arrow into p all over z dot dp the arrow. So we have this. This will be equal to p over z in bracket times phi times dp dt in bracket 1 all over phi dot d phi dp. Now let's use z all over p to open this bracket. If you use z over p to open this bracket, z over p times 1 all over z. Z over p times 1 all over z. Z will cancel z. We are going to have what? 1 over p. So here now we are going to have plus 1 all over p. Z over p times 1 over z. Z cancel z. We are left with 1 over p, which is this. Z over p times p into minus 1 over z square. P here will cancel this p. Z here will cancel what? 1z from here. We are going to have what? Minus what? We'll be left with minus 1 divided by what? Z dz divided by dp. So we are going to have this. So if you use z over p to open this bracket, we are going to have this expression. Let's put this one here in brackets. So we're going to have this expression. So compressibility is equal to Cf plus Cg, where Cf is equal to 1 over phi d phi over dp. Cg is equal to 1 over p minus 1 over z dz over dp. So anywhere you see 1 over phi d phi dp in this equation, you substitute Cf. And anywhere you see 1 over p minus 1 over z dz dp, you substitute Cg. And anywhere you see Cf plus Cg, you substitute what? Ct. If that is the case, this our equation becomes 2.637 times 10 raised to the power of minus 4k divided by mu multiplied by 1 all over arrow d the arrow of arrow into p all over z dot dp the arrow is equal to p over z phi dot dp dt into, now if you look at this bracket, we have 1 over phi d phi dp. We said that 1 over phi d phi dp is equal to what? Cf. So here becomes Cf, then plus, here we have 1 over p minus 1 over z dz dp. We said that 1 over p minus 1 over z dz dp is equal to what? Cg. So everything here becomes what? Cg. So if that is the case, we also said that Cf plus Cg is equal to what? Ct. So we can simply represent Cf plus Cg here with what? Ct. So we can simply write this as P divided by Z multiplied by phi times what? dP dt multiplied by what? Ct. Then write out the left hand side, which is 2.637 times 10 raised to the power of minus 4k all over mu times 1 all over arrow the arrow of arrow into p all over z dot dp divided by the arrow. So we have this. Since we already have this, the next step now is to divide through by 2.637 times 10 raised to the power minus 4k over mu. Divide through by the constant. So the next step is to divide through by this. So if we divide through by this, we are going to have, for the left hand side, now we are going to have what? 1 all over what? Arrow d the arrow of what? Of rho p all over z dp dr. Remember, we divided through by 2.637 times 10 raised to the power minus 4k all over mu. So we are going to have this equal to, now, if we divide through by this, at the right hand side, we're going to have what? The inverse, right? If we divide through by this, at the right hand side, we're going to have the inverse, which will be mu divided by 2.637 times 10 raised to the power of minus 4k. Now remember that at the right hand side, we have phi, we have ct, we have p over z, and we have what? dp dt that are what? Multiplying. So if this thing also is also multiplying everything here, you can simply write this thing now as what? Mu, everything here, which is mu, times what? Times phi times ct. So you can simply say that this is multiplying phi, multiplying what? Ct, and also multiplying what? P all over what? Z, and also multiply what? dp dt. You can simply say that this is the same thing as this. So this equation now is what? This equation is called the diffusivity equation for compressible fluid, the radii flow. Diffusivity equation for compressible fluid. So this will be the end of our class for today.